What if one day, carbon disappeared from the universe? What would be the consequences of such a scenario? Well, the answer is simple. There would be no consequences because there would be no one left to witness them. Why? Because carbon is everywhere. It is in the food that we eat, the clothes that we wear, the books that we read. It is in everything. Isn't that amazing? It is even in us. There are more than 1 million carbon compounds, and this is the reason that we have a whole chapter dedicated to carbon and its compounds. So, in this video, we will get to know some interesting details about carbon such as: what are covalent compounds? Types of covalent compounds. Some common covalent compounds. And properties of covalent compounds. So, when we talk about carbon, we know that its atomic number is 6, and its mass number is 12. And as you recall, the number of electrons and protons is equal to the atomic number. So carbon has 6 electrons and 6 protons. The number of neutrons is given by mass number minus atomic number is equal to 6. But for now, let's focus on the electrons. What is the electronic configuration of carbon? As you have studied in class 9th, an atom has shells named K, L, M, and N. The K shell should contain 2 electrons, and the L shell should contain 8 electrons to be stable. Now carbon has 6 electrons. Let's fill these electrons starting from the innermost shell. 2 electrons go in K shell. Now L shell needs 8 electrons to be stable, but carbon now has only 4 electrons left. So, L shell will contain 4 electrons. Now as you can see, L shell, the outermost shell of carbon, has space for 4 more electrons, and so it has a valency of 4. Now, tell me, is carbon stable? Let's talk about the concept of stability. Elements combine to form compounds to achieve a more stable and lower energy state. And what is a stable state? When the outermost shell of an element is completed, we call it a stable state. For example, carbon has 4 electrons in its outermost shell. If it gets 4 more electrons, it will have 8 electrons in its outermost shell and it will become stable. Remember this golden rule: every element is trying to reach stability while forming compounds or bonds. So, carbon is not stable as it is. So, how does it become stable? You might recall the concept of ionic bonds, in which atoms either donate electrons or take electrons, and think that carbon can either give away 4 electrons or take 4 electrons. But it cannot. The reason being that it will take a lot of energy for carbon to donate its 4 electrons. So, you might think, okay, then it can take 4 electrons. Well, no, because then it will have too much negative charge on it and will be highly unstable. Well, carbon found the solution to this problem. It becomes stable by sharing its electrons with other atoms of carbon or atoms of other elements. So, sharing is caring, even at the atomic level. Now, look at these atoms here. Carbon has 4 valence electrons and 4 hydrogen atoms have 1 valence electrons each. Now, see what happens. They share their valence electrons to form a molecule. This molecule is called methane, and a bond is formed. The bond that is formed by the sharing of an electron pair between atoms is called a covalent bond. And the molecules that are formed by covalent bonds are called covalent compounds. So, carbon mostly forms covalent compounds. When we talk about covalent compounds, we have different types of bonds: single, double, and triple. A single covalent bond is formed by the sharing of one pair of electrons between 2 atoms. For example, hydrogen molecules. A double covalent bond is formed by the sharing of 2 pairs of electrons between the 2 combining atoms. An example of a double bond is an oxygen molecule. A triple bond is formed by the sharing of 3 pairs of electrons between the 2 combining atoms. For example, nitrogen molecule. And remember this, one bond contains two electrons that are shared between two atoms. So, if there is one bond, then two electrons are being shared. Two bonds and four electrons are being shared. Three bonds and six electrons are being shared. Now, let's talk about the simplest of all molecules, hydrogen, H2. A hydrogen molecule is made up of two hydrogen atoms that share their electrons. Each hydrogen atom has only one electron, which means it has an incomplete outermost shell. But when two hydrogen atoms come together, they can share their electrons to complete their outermost shell. This sharing of electrons forms the covalent bond, also known as the HH bond. An oxygen atom has 6 electrons in its outermost shell and needs 2 more electrons to complete its octet. When two oxygen atoms come together, they share 2 electrons each, forming a double covalent bond. This sharing of electrons leads to the formation of the O2 molecule, which is responsible for the air we breathe. Nitrogen has an atomic number of 7 with 5 electrons in its valence shell and needs 3 more electrons to complete its octet. Two nitrogen atoms share 3 electrons each to form a stable N2 molecule. The nitrogen molecule has a triple covalent bond between the two nitrogen atoms. As discussed before, nitrogen needs 3 more electrons to complete its octet, and hydrogen needs 1 electron to become stable. One nitrogen atom shares 3 electrons with 3 hydrogen atoms, each hydrogen atom sharing 1 electron, to form a stable NH3 molecule. The nitrogen atom now has a full octet. So, if you observe, only the outermost electrons are involved in the bonding. Now, let's talk about the properties of covalent compounds. One of the important properties is the intermolecular forces of attraction. Imagine, if I hold your hand very tight, it's hard to break it, right? But if I hold it gently, you can easily pull it away, right? This is the case of covalent bonds. In the case of covalent bonds, very little energy can break the force of attraction that is present between the molecules, because of which they have low melting and boiling points. So, even if you provide less heat and less energy, they can easily melt and boil. And that's why they are generally in a liquid or gaseous state, because of weak intermolecular forces of attraction. Alright, the next important property of covalent compounds is that they are poor conductors of electricity. Let me give you an example. In a beaker, we have put pure water and have connected the bulb through the circuit. Tell me, will it glow? Now, this does not contain any ions, right? We all know that because H2O is a covalent compound and not an ionic compound. So, there are no free ions that are present in this, because of which it cannot conduct electricity. And if it cannot conduct electricity, what will happen to the bulb in the circuit? Will it glow? So, the bulb in the circuit will not glow, because pure water is a poor conductor of electricity. That's all. So the next time you look at your surroundings, think about carbon and how it is present everywhere around us. A common thing that connects us all. And that is why a whole chapter of science is dedicated to this element. We hope that you have understood the concept of carbon and its compounds. Now, here's a secret on how you can study effectively with the EduRev app. You can learn with chapter notes, watch video lectures, and solve NCERT-based MCQ tests of this chapter on EduRev. And that's not all, you also get amazing courses for Class 10 and much more for your Class 10 preparation. Thank you.